This is a Master 2021 conference presentation. Our title is Automatic Part of Speech Tagging for Security Vulnerability Descriptions. Security vulnerability descriptions, or SCVDs, are full of software-specific names, number sequences, and domain-specific terms. So identifying the token functional role within the SCVDs and annotating each of the tokens has a downstream applications. Models trained with natural language documents such as Pentribank are inadequate for annotating vulnerability texts because these approaches do not use any domain-specific training data. On the other hand, manually labeling training data can achieve best performance. However, annotating data requires much human effort. So our idea is to construct a neural network architecture that trains source model on large newswire corpus, and then we use the learned knowledge of this model as a prior knowledge for target model. Here is our approach, an overview framework of our approach. The first step is corpus preparation. We scrap vulnerability database and we create an annotated corpus. The second step is we merged with the Pentribank and we apply the domain-specific tokenizations. Based on the tokenization, we apply word embedding and then we build a post tagger. As you can see here, because we don't have labels for supervised learning, we use a Pentribank for the source model, and for fine-tuning purpose, we manually label vulnerability data and we use it for fine-tuning. Here is the general neural network architecture. It has two important components, the character embedding and word embedding. They concatenate and used as an embedding layer of the architecture. There is two layers here, two bytes we use, and they learn and finally send the output for prediction, the post tag of each token. The fine-tuning, we use the available natural language text to train the source model, and we transform the features and weights of the source model to the target model. Our approach has four research questions. The first one is the effectiveness of our post tagger. As you can see here, the precision, recall, and F1 is better than the well-formatted text. Secondly, because we don't have any domain-specific post tagging in vulnerability domain, we use Stanford and entity standard taggers. As we can see here, the accuracy, precision, recall, and F1, our fine-tuned post tagger has better performance. We also apply our own word embedding, whether it has an impact for the accuracy of the post tagger. As you can see here, our post tagger can have better performance with the domain-specific unsupervised word embedding. In conclusion, we believe that the finding from this work, including the published resources, will have a footprint for the future states. In the future, we plan to introduce a new post tags and extend our work for post tagging of software engineering discussion forums. Thank you very much.